In the vastness of space, most of the rocky objects we study, planets, asteroids, and comets, belong to our own solar system. But every once in a while, something truly rare happens. A visitor arrives from another star. It all began in 2017, when astronomers spotted a mysterious object hurtling through our cosmic neighborhood. They named it Oumuamua. It wasn't like any comet or asteroid we had ever seen. Oumuamua had a strange, elongated shape, like a giant cigar, and it didn't have the glowing tail typical of comets. Even more puzzling, it sped up as it left the solar system, and scientists still aren't sure why. Was it a chunk of rock, a shard of ice, or even something artificial? The debate continues. Then, in 2019, another visitor arrived, Comet Borisov. This time, it looked more familiar. Borisov had a bright coma and a long tail, just like the comets we see closer to home. But its extreme speed, about 32 kilometers per second, and its path through space showed clearly that it came from beyond our solar system. It was the first interstellar comet ever seen up close, confirming that icy bodies from distant star systems can indeed make the long journey here. And now in 2025, we have a third visitor, and perhaps the most intriguing one yet, Comet 3I Atlas. This object is only the third ever confirmed to come from beyond our solar system. Almost every major telescope on Earth and in space has turned to observe it. And the more we look, the stranger it becomes. For one, 3I Atlas seems to be changing color as it approaches the inner solar system. That's not something we typically see. It's behavior that doesn't quite match that of any known comet, and that's exactly what has scientists so intrigued. So, what exactly is this object? What sets it apart from Oumuamua and Borisov? And why are researchers calling it extraordinary? In this video, we'll take you through the fascinating story of 3I Atlas, how it was discovered, what different telescopes around the world have found, and what this rare visitor might be telling us about other planetary systems across the galaxy. The story of Comet 3I Atlas began on the night of July 1st, 2025. At an observatory in Chile, a telescope from the Atlas project spotted something unusual. Atlas was designed to monitor the skies for asteroids that could potentially pose a threat to Earth. It does this by scanning the sky night after night, looking for tiny points of light that move differently from the background stars. But this time, the object it detected didn't behave like any typical asteroid or comet. It was located about 4.5 astronomical units from the Sun, roughly the same distance as Jupiter, and it appeared to be moving unusually fast across the sky. Its motion didn't match anything familiar, and astronomers quickly realized this object deserved a closer look. Within hours, telescopes in Hawaii, Arizona, and Chile were all pointed towards the mysterious traveler. The images they captured revealed a faint halo of gas and dust, a coma surrounding the object, along with the beginnings of a short tail. This was no inert rock, it was a comet, already beginning to release volatile ices as it neared the inner solar system. Then came a breakthrough. Astronomers began digging through archived data, looking for earlier images that might have accidentally captured the comet before its official discovery. And they found them. The Zwicky Transient Facility had photographed the object in mid to late June, and Atlas itself had unknowingly recorded it even earlier. With these pre-discovery sightings, scientists could now trace a longer segment of the comet's path. This made it possible to calculate its orbit with far greater accuracy. And the results were astonishing. 3I Atlas wasn't bound to the Sun at all. Its trajectory was extremely hyperbolic, meaning it wasn't looping around the Sun like most comets do. Instead, it was on a one-way trip, flying through the solar system at a speed and angle that could only mean one thing: it came from another star. On July 2nd, the object received its official name, 3I Atlas. This marked a historic moment. For just the third time in history, humanity was observing a visitor from another star system. But here's where things get even more exciting. It turns out the comet had been hiding in plain sight, long before its official discovery in July. The breakthrough came thanks to NASA's Transiting Exoplanet Survey satellite, better known as TESS. Although TESS was designed to search for planets around distant stars, it also takes wide-field images of the sky every 30 minutes, and what they found was unexpected. Even at a distance of 6.4 AU from the Sun, far beyond the orbit of Jupiter, the comet was already active. That's unusual, because water ice, the main driver of activity in most comets, doesn't sublimate at such cold distances. This meant something else had to be fueling it, something more volatile. The most likely culprits: carbon monoxide and carbon dioxide, ices that can vaporize in much colder conditions. This was the first clue that it wasn't a typical comet formed in our solar system. Its behavior hinted at an exotic chemistry, shaped in the cold, distant reaches of a completely different star system. One of the most important questions people ask is that how do we know that it's an interstellar object? The answer doesn't lie in chemistry, but in its orbit. Its path through the solar system was extreme, far more so than anything we've seen before. The first clue came from its eccentricity, a number that tells us how stretched an orbit is. Objects bound to the Sun, like planets or regular comets, always have eccentricities less than 1. But 3I Atlas? It had an eccentricity of about 6.1, a staggering value. This meant the Sun barely curved its path at all. Instead of looping around the Sun like a typical comet, 3I Atlas was essentially flying straight through the solar system, as if it were cutting across lanes on a cosmic highway. The comet's speed told a similar story. Its hyperbolic excess velocity, the speed it retains even after escaping the Sun's gravitational pull, was clocked at about 58 kilometers per second. That's more than twice as fast as Oumuamua and significantly faster than Borisov. And as it swings around the Sun in late October, it's expected to hit speeds of 68 kilometers per second relative to the Sun, making it the fastest interstellar object we've ever observed. Such speed doesn't just happen. It points to a long and chaotic journey through interstellar space, like shaped by countless gravitational encounters with stars, planets, or even massive clouds of gas and dust scattered across the galaxy. When 3I Atlas was first captured by the Atlas telescope in Chile on July 1st, it appeared as nothing more than a faint point of light, almost indistinguishable from the background stars. At that moment, there was no way to tell if it was an asteroid or a comet. But that changed quickly. Just a day later, on July 2nd, the powerful Canada-France-Hawaii telescope turned its gaze toward the object. The new images revealed something subtle but significant: a marginal coma, a faint halo of gas and dust that surrounds the core of a comet. That faint glow was enough to confirm it. This was an active comet, not just a rocky asteroid. Then came a major breakthrough. On July 4th, the Very Large Telescope in Chile captured a stunning sequence of the comet drifting across a background of stars. Over the course of 13 minutes, the object moved across the image as a series of bright dots, confirming its motion through the solar system. But it wasn't just a pretty picture. That night, spectroscopic observations made by the VLT revealed two key discoveries. First, the object's interstellar origin was confirmed with high precision. Its motion, speed, and orbit left no doubt. This was a visitor from beyond the solar system. Second, and just as exciting, traces of atomic nickel and cyanide gas were detected in the comet's coma. These elements are also commonly found in comets of the solar system. This discovery provided direct chemical evidence that comets from other planetary systems may share similar building blocks with those in our own. It supported a growing idea in astronomy that the ingredients for comets and possibly even life might be common across the galaxy. Comet 3I Atlas looked like just another moving speck in the sky, but when we studied it closely, everything changed. And that got me thinking, what else might we be misreading simply because we're not looking closely enough? Not in space, but in the world around us. Most of us only see a narrow slice of reality shaped by the outlets we follow and the region we live in. And when it comes to science news, it gets even trickier. Headlines are often exaggerated or oversimplified to get clicks. That's why I use Ground News. It's a platform that helps you cut through bias and hype by comparing how different media outlets are covering the same story. It shows you political slant, headline framing, and even what stories you might be missing entirely. For example, when this new discovery broke, I used Ground News to ensure I was reading balanced, credible coverage. I could instantly check each outlet's factuality rating, which is verified by 3 independent organizations. For every story, they also show the bias distribution, ownership, and where each reporting source is located. And here's something cool. The founder of Ground News is a former NASA engineer, so you'll find a strong foundation for trustworthy science coverage too. My favorite feature? The blind spot. It highlights stories that are disproportionately covered by one side of the political spectrum, so you're always aware of what your feed might be leaving out. If you're only interested in topics like science, the interest pages filter out the noise and show you only what matters to you. There's a special offer for viewers of this channel. For a limited time, you can subscribe and get 40% off the Unlimited Access Vantage plan by scanning this QR code on the screen or heading to ground.news/SOU. The link is also in the description. Now back to space. As Comet 3I Atlas continued its journey toward the inner solar system, more observatories joined the campaign to study this rare visitor. One of the next to turn its powerful eye towards the comet was the Gemini North Telescope in Hawaii. Gemini North captured detailed, high-resolution views of the comet, clearly showing the development of a dusty coma. To better understand what was happening, the telescope collected multicolor images across both visible and infrared wavelengths. These images revealed noticeable shifts in color, partly due to the filters used, but also due to changes in the comet's own physical behavior. Data from Gemini North showed a dramatic surge in gas emissions, especially cyanide and atomic nickel, the same exotic gases first detected by the VLT. The next telescope to lock eyes on Comet 3I Atlas was none other than the legendary Hubble Space Telescope. On July 21st, Hubble pointed its 2.4-meter mirror towards the fast-moving interstellar comet and captured the sharpest image of it to date. And from this single observation, 3 major discoveries emerged. First, Hubble's high-resolution images helped astronomers estimate the size of the comet's nucleus, the solid core hidden beneath all the gas and dust. While not directly visible, the data allowed scientists to place new constraints on its diameter, suggesting it's most likely smaller than 1 kilometer, though possibly as large as 5.6 kilometers. That makes it comparable in size to most solar system comets. Based on its estimated size, 3I Atlas has a minimum mass of around 33 billion tons. That makes it 1,000 to 1,000,000 times more massive than the 2 previous interstellar objects combined. In terms of sheer scale, this is the largest interstellar visitor we've ever observed. Second, Hubble revealed something more dynamic, a visible plume of dust being actively ejected from the comet. This striking feature was direct evidence that 3I Atlas was strongly outgassing, releasing frozen material as it warmed under the sun's light. The activity suggested that the comet's surface was already beginning to break down, releasing ancient ices into space. Third, data from the observation showed that the comet was speeding through the solar system. This incredible speed aligned with models suggesting that 3I Atlas had been drifting through interstellar space for billions of years. Its course shaped and accelerated by past gravitational encounters with stars, gas clouds, and perhaps even unseen planets in distant systems. But the biggest surprise was yet to come. On August 6th, the most advanced space telescope ever built, the James Webb Space Telescope, turned towards 3I Atlas. By this point, the comet had drawn closer, reaching a distance of about 3 AU from the Sun, roughly 3 times the Earth's sun distance. At that range, temperatures are typically high enough for water ice to sublimate, creating bright, water-rich comas around most comets. But 3I Atlas didn't follow the usual script. Webb's infrared instruments detected something astonishing. The comet's coma contained an unusually large amount of carbon dioxide, far more than water. In fact, the carbon dioxide to water ratio was about 8:1, which is 16 times higher than what we usually see in solar system comets at this distance. This pointed to something truly alien about 3I Atlas. It likely formed in a planetary system where carbon dioxide ice was more abundant than water ice. Why would that happen? When planetary systems form, different ices condense at different distances from the central star. If 3I Atlas's home star blew away the water vapor early, before comets could form in the inner icy regions, then the outer regions might have been dominated by carbon dioxide ice instead. That could explain why 3I Atlas is so rich in carbon dioxide today. There's another possibility too. Some scientists suggest that 3I Atlas may have passed close to another star long ago, an event that could have stripped it of its surface water ice. Others propose that the water may still be buried deep beneath the comet's crust, insulated from sunlight and harder to detect, though such thermal shielding would be unusual. Whatever the cause, the chemistry of 3I Atlas doesn't match anything we've seen in comets from our own solar system. It hints at different formation environments, different histories, and perhaps even different types of planetary systems scattered across the galaxy. Despite everything we had learned, its size, speed, chemistry, and behavior, one mystery still lingered. Where did 3I Atlas come from? And just how old is this ancient traveler from the stars? To answer those questions, astronomers turn to the one mission that knows the Milky Way better than any other. ESA's Gaia telescope. Launched in 2013, Gaia has spent years mapping over 1 billion stars in our galaxy, tracking their motions, distances, and positions in 3D. It's essentially created a stellar map of the Milky Way, making it the perfect tool to retrace the path of an object like 3I Atlas. Using Gaia's data, researchers track the comet's motion backward through time, simulating its journey across interstellar space. They were able to trace its trajectory over the last 4.27 million years, identifying 62 stars it may have passed along the way. But here's the surprise. None of those stars had a strong enough gravitational pull to significantly alter the comet's course. That means 3I Atlas didn't originate anywhere near our solar neighborhood. Instead, Gaia data pointed to a more distant and intriguing birthplace, the boundary between the Milky Way's thin and thick disks. This is a transitional region of our galaxy, where the youngest stars of the thin disk meet the ancient stars of the thick disk. If 3I Atlas truly came from this region, It could be a relic from the early days of the Milky Way, possibly over 10 billion years old, making it twice as old as the Sun. In other words, 3I Atlas isn't just a visitor from another star. It may be a time capsule from the early galaxy itself, carrying the icy fingerprints of a world that formed when the Milky Way was still young. As 3I Atlas races away from the Sun and prepares to exit our solar system forever, it leaves behind more than just a glowing trail of gas and dust. It leaves us with questions, possibilities, and a deeper sense of connection to the galaxy beyond. In just a few months, this icy relic from another star system gave us a glimpse into the chemistry, motion, and mystery of worlds we may never see. And though it will soon vanish into the dark, its brief visit has forever expanded our perspective just like its two known predecessors, reminding us that we are part of a much larger cosmic story still unfolding across the stars. So thanks for watching, and thanks to Ground News for sponsoring this video. If you're tired of clickbait headlines and just want the real story, especially in science, scan this QR code or head to the link ground.news/SOU given in the description. You'll get 40% off the Vantage plan and finally see the news like you see the universe, clearly.